Hello, Pre-Algebra class. This is Module 6.1, Identifying and Representing Functions. Our essential question is, how can you identify and represent functions? So if we look at our Explore activity, Understanding Relationships, Carlos needs to buy some new pencils from the school supply store at his school. Carlos asks his classmates if they know how much pencils cost. Angela said she bought 2 pencils for 50 cents. Paige bought 3 pencils for 75 cents, and Spencer bought 4 pencils for $1. So Carlos thinks of the rule for the price of a pencil as a machine. When he puts the number of pencils he wants to buy into the machine applies the rule and tells him the total cost for the number of pencils. So for 2 pencils, it said it was 50 cents. For 3 pencils, it was 75 cents. For 4 pencils, it was $1. So if you break that down, each pencil should cost 25 cents. So number of pencils is going to be 0.25x, because you're going to multiply 25 cents per pencil. So this would be total cost 0.25x. So if you put in a 12 times 0.25, so 0.25 times 12 is going to be 12 times a quarter, which is $3. So any patterns? Yeah, it goes up by a quarter each time, so each pencil costs 25 cents. So how did you decide what operation to use in your rule? What I did was I found the unit rate, how much it costs for 1 pencil, and then I multiplied it by the number of pencils. So now if Carlos decides to buy erasers in a package, there are 6 pencil top erasers in 2 packages of erasers. Write a rule for the number of packages Carlos needs to buy to get X erasers. Then write the rule as an algebraic expression. So if there are 6 in 2 packages, there should be 3 pencil top erasers. So it would be y equals 3x. So now that means the x is how many packages you buy, and the y is the total number of erasers. So how many packages does Carlos need to buy to get 18 erasers? This is going to be your total number of erasers, so you have to plug that into y. So it's going to be 18 equals 3x. Then when you solve for x, remember you want to isolate the variable and get x all by itself. So if you divide both sides by 3, you're going to get 1x, and you get x equals 6. So he will need to buy 6 packages. So now we have to identify functions from mapping diagrams. A function assigns exactly 1 output to each input. So your input are going to be your x values. So if you have input, and I would write this in your notes somewhere, and then output is your y values. So a mapping diagram can be used to represent a relationship between input and output. So if you look right here, it says determine whether each relationship is a function. So if you look at number 1, 1 goes to 2. Does it go to any other outputs than 2? No. So that one right there would be a function. 3 goes to 8 and only 8, and 7 goes to 6 and only 6. So every input assigns exactly 1 output. So when you put in a 1, it only goes to 2. When you put in a 3, it only goes to 8. If it went to multiple numbers, then it would not be a function, but this is a function. Now for B, it says determine whether each relationship is a function. So 0 goes to 1, but do you see how 2 goes to 2 different outputs? So it is not a function because your 2 has 2 different outputs. So for number 3, it says, is it possible for a function to have more than 1 input value, but only 1 output value? So say we have like a 1, 2, and 3 here. Can 1 go to, we'll say 8? Can 2 go to 8 and 3 go to 8? That is a function, because 1 only has one output, 2 only has one output, 3 only has one output. So if you take a look at number 4, determine whether each relationship is a function. So 7 goes to 3, 8 goes to 1, 9 goes to 1, and 10 goes to 2. So yes, every input has one output. So it has to have exactly one output. Now look at number 5. 3 goes to 0, so the input of 3 has 4 outputs. So no, 4 outputs. So remember, you can only have one output. So that's how you can describe it from mapping diagrams. Now we have to look at tables. Remember, your input, these are your x's, your output is your y. Relationships between input values and output values can also be represented using a table. So if you look at the inputs, you see how 5 goes to 7, 10 goes to 6, 15 goes to 15, 20 to 2, and 25 to 15. That is a function because every input has exactly one output. I would write this down somewhere in your notes, just because when they ask you to explain, that's the best explanation. Every input has only one output. So if you look at this table here, just determine whether this is a function. We have an input of 1, input of 1. Do you see how 1 goes to 10 and 4? So it is not a function. So it just takes one pair to make it not a function. So for number 6, it says, what is always true about numbers in the first column in a table that represents a function? They are all different. So do you see how 1 and 1 are the same? That means it is not a function because it has two different outputs here. So if you look here for number 7, 53 goes to 53. Do you see how all the inputs are different? So this would be, yes, it is a function. So every input has one output. So now if you look at number 8, do you see these two numbers? So you have 8 and 8, and it goes to 21 and 34. That's two different outputs. So no, 8 has two outputs. Okay, and then our last part is going to be identifying functions from graphs, which is not too bad because you can do this thing called the vertical line test, where if you basically have a graph like this and you take a vertical line and it touches the points 2 times, then you can say it's not a function. So I can already tell right here, see your x values are what's on the bottom, and then your y is what's on the side. So x's are on the bottom, and there's the input of 9 right here has 2 outputs, and the input of 2 right here has 2 outputs. So I can already tell that's not a function. So you could write out every single ordered pair that's on the graph, and you can say, hey look, 2 goes to 70 and 2 goes to 85, and say that's not a function, and 9 goes to 90 and 95, which is in the blue, so it is not a function. So if you take a look at number 10, the graph shows the relationship between the heights and weights of members of a basketball team. Is the relationship represented by the graph a function? So if you do the vertical line test, this one's good. Ooh, here are actually 4 different ones. So I would say not a function, 70 inches is, or has, so we'll say at 70 inches, it has 2 outputs, and then at 71 inches, has 2 outputs. So if you recall, a function for every input, it has exactly one output. That's all I have for today. Thanks.